In this video, we are going to discuss about the input and the output characteristics of CE, CB and CC configuration, that is common emitter, common base and common collector configuration. So in simple, what is common base configuration? Common base configuration is nothing but base of the terminal should be grounded. So here the base is grounded and the other two sides, that is the common terminal of the emitter as well as the collector, which acts as the input and the output. It is also called as the grounded base configuration, and here the emitter is the input terminal and the collector is the output terminal. So here you can see the input equivalent circuit of the CB configuration. And when it comes to the input side, so here the graph determines the voltage between the input voltage and the input current, where here the output voltage we are keeping as constant. So to determine this input characteristics, the collector base voltage is kept as constant at 0 and emitter current is increased from 0. So for each variations of VCB, you can find out the values. So the curve which is obtained here as constant collector base voltage, and when there is a 0 emitter base junction, this behaves as a diode so that the emitter current increases rapidly. And in the case of the output characteristics, there is a curve between the output voltage and the output current, where here we are determining the input current as 0. So to determine this output characteristics, the emitter current is kept as constant, that is at 0, and the collector current is increased from the 0. So for the repeated values, we are finding out the value and you will getting the graph like this one. So here you can see the transistor parameters of the CB configuration. So first one is input impedance. So first, for calculating the input impedance, it is defined as the ratio of change in input voltage to the change in the input current. Here the output voltage is kept as constant. So input impedance is determined as HIB, which is equal to del VEB divided by del IE. Here VCB is set as constant. And to find out the output admittance, which is nothing but HOB, it is defined as the ratio of change in output current to the change in the output voltage with the input current is kept as constant. So here the equation is HOB equal to del IC divided by del VCB. I is set as constant. In the case of forward current gain, which is determined as HFB, is equal to the ratio of the change in the collector current to the change in the input current, that is nothing but del IC by del IE. Here the value which we are keeping as constant is VCB. And the next one is the reverse voltage gain. It is defined as the ratio of change in the input voltage to the change in the output voltage with the input current is keeping as constant. So HRB equal to del VEB divided by del VCB. Here IE is kept as constant. And this is the configuration of the C configuration. This is also the similar to kind of the CB configuration, but here the emitter is grounded. And here in the input characteristic, you can find out the variation in the input voltage and input current, and the output voltage is kept as constant. For determining the input characteristics, we are setting the collector base voltage as constant and the base current is increased here. For the repeated values, we are finding out the curve. And in the case of the output characteristics, the curve between the output voltage to the output current, and here the base current is kept as constant, and here we are increasing the collector current, and for that fixed values we are finding the curve. So here also we have three regions. One is active region, cutoff region and saturation region. In the case of active region, it is defined by the biasing arrangements. Cutoff region, there will be zero current. Saturation region, there will be increase in the current. And the same parameters which we have used for the common base configuration we'll be finding out for the common emitter configuration, but there will be change in the input impedance, that is del VB divided by del IB, where VCB is constant in the case of input impedance, and output impedance del IC divided by del VE, where IB is constant. And forward current gain HFE equal to del IC by del IB, where VCE is constant, and reverse voltage gain HRE equal to del VB divided by del VC, where IB is constant. And in the case of the CC configuration, the collector is grounded, and this is base is the input terminal and the emitter is the output terminal. In input characteristics, we are setting the emitter base voltage as constant and the base current is increased from the 0. For repeated values, we are finding out the curve. In the output characteristics, we are setting the base current as constant and the emitter current is increased from 0. So for the fixed value, we are finding out the value of IB current. The same thing here also, we are finding out the transistor parameters for input impedance, output admittance, forward current and reverse voltage gain. For each of the things, we are setting some voltage or current as constant to find out the variation in the input impedance, output admittance, forward current gain and reverse voltage gain. Thank you.